For as long as humans have gazed at the night sky, Betelgeuse has captured our attention. Situated on the shoulder of Orion the Hunter, this massive red star glows with a distinct reddish hue. It's one of the largest and most luminous stars we can see with the naked eye. But Betelgeuse isn't just impressive, it's also dying. In 2019, something strange happened. This star suddenly dimmed a lot to astronomers around the world. It was an alarming change. Many speculated that it was about to blow into a supernova, lighting up our skies for several weeks. However, Betelgeuse gradually brightened again in early 2020, back to its normal appearance. But the event raised even more questions than answers. Why did it fade so dramatically? Why has its brightness always been so irregular? Could something else be interfering with its light? Now, years later, astronomers have found a missing piece of the puzzle. They have finally discovered another star locked in a close fateful orbit with Betelgeuse, confirming a hypothesis that was proposed more than a century ago. This groundbreaking discovery is going to reshape our understanding of Betelgeuse. So, how did astronomers finally manage to spot the elusive companion of the red supergiant Betelgeuse? Why did it remain hidden for so long, even from our most powerful space telescopes? Finally, and most importantly, what fate awaits this tiny companion when Betelgeuse eventually goes supernova? Great dimming. The story of the discovery of Betelgeuse companion is quite interesting. It all began with the Great Dimming of 2019. Over the course of a few weeks, Betelgeuse brightness dropped to just 35% of its usual brightness. Astronomers later found out that the dimming wasn't due to something happening inside the star. Instead, it appeared that Betelgeuse had ejected a huge cloud of gas. As this gas cooled, it condensed into dust, which then drifted in front of the star and blocked some of its light from our view on Earth. Betelgeuse soon returned to its normal brightness. But the Great Dimming episode turned astronomers' attention to something mysterious about Betelgeuse that has always puzzled them. Its pulsating cycles. Betelgeuse is a bit of a rhythmic breather. It pulsates, meaning its outer layers regularly expand and contract like a slow-motion heartbeat. But here's where it gets interesting. It doesn't have just one rhythm. It has multiple overlapping cycles. The first is the main pulsation cycle of 400 days. Roughly every 400 days, the star slowly swells and shrinks. This is due to changes in pressure and temperature in its outer layers, causing it to brighten and dim slightly over time. But there's another much slower cycle, one that's far more puzzling. About every 6 years, Betelgeuse gradually brightens and dims again, though much more subtly. And despite decades of observations, no one knows exactly what causes this longer rhythm. The second clue: it wasn't just Betelgeuse brightness that changed. Its motion did, too. Specifically, astronomers noticed changes in its radial velocity. The speed at which the star moves toward or away from us along our line of sight. To picture this, imagine watching a car drive straight toward your camera and then away from it. That direct in and out motion is what radial velocity measures, not sideways movement, just forward or backward from our point of view. Astronomers detect this kind of motion using a phenomenon called the Doppler shift. When a star moves toward us, its light waves get compressed, shifting light slightly toward the blue end of the spectrum. If it moves away, the light stretches out and shifts toward the red. By carefully measuring how the star's light shifts over time, scientists can figure out how fast it's moving along that line. But here's where it gets interesting. If a star's radial velocity changes in a smooth repeating pattern, it's usually a sign that something is orbiting it, like a planet or another star. That's because of gravity. When a star has a companion, the two don't just orbit separately. They both revolve around a shared center of mass. As a star gently gets pulled toward and then away from us in its orbital dance, its light rhythmically shifts between blue and red. In Betelgeuse's case, this exact pattern appeared. Astronomers dove into over a century's worth of data, analyzing both modern radial velocity measurements and historical spectroscopic plates, some dating all the way back to the early 1900s. What they found was astonishing: a consistent repeating cycle. The data revealed that the star's radial velocity wobbled in a smooth wave-like pattern roughly every 2,100 days, which is about 5.78 years. This finding was a turning point in the story. For the first time, scientists had strong long-term evidence of two separate behaviors. Betelgeuse brightness and its radial velocity both changing on the same timescale of about 6 years. That kind of alignment wasn't likely to be a coincidence. It strongly hinted that something was orbiting Betelgeuse and tugging on it, affecting both its motion and its light. With this the confidence grows discovery, the binary theory gained fresh momentum. The evidence was mounting, and now astronomers were more confident than ever. A companion star had to be there. It was no longer a question of if. It was only a matter of when they would finally be able to see it. At the same time, another research team approached the mystery from a different angle. Their findings pointed to a fascinating possibility. The suspected companion star might occasionally pass through Betelgeuse's extended bloated atmosphere. As it moves through this region, it could disturb the surrounding gas and dust, causing fluctuations in how much light reaches Earth. But there was still one big problem. No one had actually seen it. Even some of our most powerful observatories, like the Hubble Space Telescope and the Chandra X-ray Observatory, had scanned the region around Betelgeuse in search of a companion. Yet, they found nothing. This suggested two possibilities. Either the companion is extremely faint, or it's orbiting so close, just a few astronomical units away from Betelgeuse, that it's completely lost in the star's brilliant glare. In other words, if it really exists, then it's been hiding in plain sight all along, shrouded by the brightness and chaos of a dying supergiant. But there was a silver lining. Even though the companion hadn't yet been seen, the new models provided something incredibly valuable, a prediction. They calculated when and where the companion would be easiest to spot. According to their results, the companion was expected to reach its maximum angular separation from Betelgeuse in late 2024. This means it would appear farthest from the star in the sky at that time, making it just a little easier to distinguish from Betelgeuse's overwhelming glare. The models didn't stop there. They also estimated how bright the companion might be and its exact position relative to Betelgeuse. The stage is set with all this information in hand. Astronomers now had a rare opportunity, a brief, well-timed window to try to finally capture a direct image of the elusive star that had hidden in plain sight for so long. And finally, the moment arrived. A team led by Dr. Steve Howell prepared to test the predictions. On December 9, 2024, the Gemini North Telescope in Hawaii turned its gaze toward Betelgeuse. Mounted on it was a powerful instrument called the ALO, a high-speed camera designed for one very special task, capturing details too fine for ordinary telescopes to see, especially when they're blurred by Earth's atmosphere. It was right there. When the Gemini team observed Betelgeuse in December 2024, they saw something remarkable. Just 0.05 arcsec from the center of Betelgeuse's disk, a distance equivalent to the apparent width of a human hair from 10 kilometers or 6.2 miles away. A tiny faint point of light appeared. This separation translates to about 4 astronomical units or roughly the distance between the Sun and Jupiter. The object was about 6 magnitudes dimmer than Betelgeuse. So faint that it had remained completely invisible in earlier images, including those taken in 2020. But in December 2024, it finally appeared. And not just anywhere. It showed up exactly where astronomers had predicted the companion would be based on orbital models. Although the detection was faint, right at the limits of what the instruments could register, everything else fit with striking accuracy. The position, timing, and brightness of the object aligned almost perfectly with expectations. Are you sure? But how could the team be sure this faint object wasn't just a distant background star or some unrelated source that happened to pass behind Betelgeuse at the right time? That was one of the most critical questions the researchers had to answer. To test this, they compared the object's position relative to Betelgeuse with what would be expected if it were a background star. Betelgeuse has a large and well-measured proper motion, meaning it moves noticeably across the sky over time. So, if the faint object were a distant background star, its position would appear to shift over the years as Betelgeuse moved in front of it. To check this, the team looked back at archival images from the Gemini telescope taken in 2020. If the source were a background star, it should have been visible at a different position then, but it wasn't. There was no sign of it in the spot where a background object should have been. More importantly, The faint source in 2024 appeared exactly where models predicted a gravitationally bound companion would be based on the star's 6-year radial velocity cycle. Her bracelet, the discovery of this faint companion, has opened a fascinating new window into the structure and evolution of this famous system. Based on its brightness, astronomers estimate that the companion has a mass between 1 and 1.5 times that of the Sun. Interestingly, it might be a pre-main sequence star, meaning it's still in the early stages of development and hasn't yet begun the steady hydrogen fusion that defines a fully mature star. That possibly fits with the idea that both stars likely formed together from the same collapsing molecular cloud, but their life stories couldn't be more different. Betelgeuse, originally between 15 and 20 times the mass of the Sun, has evolved quickly. Massive stars live fast and die young, and Betelgeuse is now nearing the end of its life, swollen into a red supergiant on the brink of collapse. In contrast, its companion, far smaller in mass, is just getting started. Still slowly preparing for its long stable life as a main sequence star. In a striking contrast, one star is racing toward death while the other is still preparing for its long life ahead. In recognition of this unique pairing, astronomers have proposed a name for the likely companion. Siwara, an Arabic word meaning her bracelet. The name is fitting. Betelgeuse itself comes from the Arabic word meaning the hand of Orion. With Siwara orbiting so closely, the name beautifully reflects its intimate relationship to the giant. Not a distant partner, but something held close, circling like a bracelet around a fading wrist. But as exciting as the discovery of a companion is, its future appears grim. The faint star orbiting Betelgeuse doesn't seem destined for a long or peaceful life. Its orbit lies just outside Betelgeuse's swollen outer layers, which means it may be already moving through the extended atmosphere of the dying supergiant, and that's dangerous territory. According to current models, Betelgeuse's powerful tidal forces are likely tugging on the smaller star, slowly pulling it inward. Over time, this gravitational drag could cause Saura's orbit to decay. In fact, astronomers estimate that within the next 10,000 years, a blink of an eye in cosmic terms, Sierra could spiral into Betelgeuse entirely. If this happens, the two stars will merge just before Betelgeuse ends its life in a supernova explosion. The road ahead beyond solving long-standing mysteries about Betelgeuse, this discovery opens a new chapter in our understanding of red supergiants. If Betelgeuse's strange behavior, its brightness cycles, its motion, can be explained by the influence of a hidden companion, it raises a much bigger question. Could other red supergiants be hiding partners too? Take Antares for example, another massive red supergiant in the constellation Scorpius like Betelgeuse. An entry shows long-term variations in brightness that scientists have struggled to explain. With Betelgeuse now merging as a likely binary system, Antares may become a prime candidate in the search for unseen companions. This discovery could mark a turning point, shifting the way astronomers study aging stars and prompting a fresh look at how stellar companions might be quietly shaping the lives and deaths of giants across our galaxy. So, thanks for watching. Recently, astronomers unveiled the first images captured by the largest digital camera ever built for astronomy, and they are truly breathtaking. If you haven't seen them yet, don't miss our episode where we break down these stunning images and what they reveal about the universe. Be sure to check it out.